me find it. Okay, so this is one with people driving cars and you want to figure out when one passes another. So it tells you David is going at a constant acceleration of 25 meters per second. Now the reason I'm running x equals 25t is because we know that the displacement is equal to the time times 25, since that's her speed. And then for Tina, we know that there is an acceleration, which means we want to find the slope of the velocity is 2.2 times time. Now notice that since this is slope of the displacement function, that is velocity, and since this is the slope of the velocity function, that is acceleration. And it wants to know when, first of all, how far does she have to drive before passing David? So it wants to know when their displacement is the same. So first of all, I have to figure out Tina's formula for displacement. And if I know her formula for velocity, I can take the antiderivative, since we have x, v, a, and going up is antiderivative. And so we have x for Tina equals 2.2, but it's t squared. 2.2 divided by 2 is 1.1. And we know that her initials were both 0, so we don't have to do anything else. So now these are the two equations that we have for their position. We want to make this one equal this one. So if x equals x, that means that this equals this. 1.1 t squared equals 25t squared. So then if we subtract it over, t squared minus 25t, oh, this is not squared. Bad, because there's no square here, don't bring a square here. 25t equals 0. And so then we're solving for t again, and so we can use the quadratic formula to find that, and we get negative b plus or minus the square root of b squared, so 25 squared, and then minus 4ac, but there's no c value because there's no constant, which means that cancels out, and then that's all over to a. A is 1.1, 2.2. So we have 25 plus or minus 25 over 2.2. And we have 25 minus 25 equals 0. 0 divided by 2.2 is 0, which means that at time 0, velocity is 0, or that their displacement, or that their displacement is the same when time equals 0. And we already know that since they're starting in the same place. So if we add 25, though, we get 50 divided by 2.2. And this equals 22.73. I'm going to use 22.73 since I just showed you how I got that. 22.73 seconds. Because that is time. So that's how long it takes for her to pass. So then we can just take this and plug it back into the simplest equation and plug in this for time. And if you multiply 25 times 22.73, you get 568.25. And that tells you how many meters they have traveled. And then we look at significant figures, and you see that there's 3 in the problem because we have 2.20 and 25.0. So we can take that off. And we have 568 meters as our answer for part A. Now for part B, we're trying to figure out what speed it is she passed them. I'm going to save this because this knows what time they passed. So we want to know what speed was she at as she passed them. So we're trying to find a specific point in time, which means we're going to need to use formulas and derivatives. Because whenever it's a specific point in time, that's when you use the derivatives. If you're trying to find the difference or average, that's when you're going to have to use the formula above it and then do subtract largest from minus divided by delta time. So, but for this problem, we know that it took 22.73 seconds to pass them, and that her velocity is 2.2 times that time. So we just do 2.2, since that's her acceleration rate, times 22.73, which is the time that it took to get you her velocity, because that's what this equation is. And that gets you her velocity of 50 meters per second. Because if we remember, the way we got this is by dividing 50 by 22.2, or not 22.2, 2.2. That's how I got this so fast. Okay, so that's how you get part A and part B to that problem. Next problem is going to be 2.33 on Mastering Physics for the practice, so give me just a second to set that up. Okay, 2.33. It says a particle moving along the x-axis has its position described by the function x equals, so we know we're given a displacement function, x equals 5t cubed, plus, that's a t not an f by the way, I know they look the same, not plus, minus 1t plus 4, and this is in terms of meters because it's displacement. Okay, now it wants to know 3 things. It wants to know all of them at 2 seconds. So we know t is always equal to 2. And it wants to find at 2 seconds, which means we're going to have to use the formulas and use the derivatives again. So we have x v a. As we go down the ladder, we have to use derivative. So it wants to figure out, first of all, the particle's position. Well, that one's easy because we have the formula for position. So we just have to plug 2 into all of that. And once you do that and plug it into your calculator, you get 42 meters. And then it wants to know what the velocity is. And so in order to get that, we have to take the derivative of this function. And in order to do that, same rules for all derivatives, 15t squared minus 1. Because that goes away, that just loses its t. So we know that's the equation for v, and we just have to, again, plug in 2. Plug in 2, and you get 59 meters per second. As that's the velocity at 2 seconds. And then it wants to know acceleration at 2 seconds. So we just have to find, again, the derivative, since we're just going down the ladder one more step. So 15 times 2, 30, times t, and then that goes away. So 30 times 2 equals 60. And that's meters per second. That's great. And then up here, that was 42. Okay, let me know if you have any questions or if there's any part I stumbled through that you want me to clarify or anything like that. Okay, good luck. Let me know if you need anything. Oh, remember, 5 things. X v a, going down, that's thing number 1. That's D. Up is 80. Your 3 formulas. X equals 1/2 at squared plus initial velocity plus initial displacement. Velocity equals acceleration times time plus initial velocity, and velocity squared equals initial velocity plus 2, or that's squared, plus 2a delta x. If you want me to do a specific problem, just message me, I'll work it out, I'll send it to you. I work through how to do it by this method, because as you saw, I was able to do all this on one little whiteboard. So your first thing is getting that in order from smallest to biggest. Second thing, derivative and antiderivative, know which direction they go, and then 3, 4, 5. These 3 are all going to be given to you. This is the only part you have to know at all. There you go.